Hello everyone, welcome to my channel. So today we are going to do blind 75's one of the question, invert binary tree. So in the series of trees, now this is the next question which we are going to solve. So before coding this particular question, we'll check out the whatever the question says and whatever constraints are there so that we can think about the implementation part for the same and whatever possible solution could be there and why we chose our solution and whatever the time complexity and space complexity would be there. So let us first read this question. So here if we see, so we are given the root of a binary tree, invert the tree and return its root. So what does invert refers to here? That we need to check out from the examples given, and the constraint which is mentioned that number of nodes of the tree is in the range 0 to 100. So that is pretty much lesser number of nodes only. And node values are also from minus 100 to 100. And here with values we are not concerned that much. What we are concerned with is the number of nodes which are there and how we need to invert the tree. So here if you check the first example which is there, so in the first example if you see, so here the 4 which is there, that is as it is. Then on the left hand side we have 2, but here on the left side we have 7. Then on the right hand side we have 7, but on the right hand side we have 2. So if you see how the things are, so these are the mirror images of each other. So if here is 4, then in new tree also 4 is there, but if here is 2, then not on the left side but on the right side, that 2 should be there, and whatever on the right side is there, that should be on the left side. So like that we need to invert the tree which is being given to us. So basically in this, now we got the question that what exactly we are required to do. Whatever is on the left, we need to swipe, basically we need to just swap it with the right hand side whatever is there. So that is what we are required to do here. So I hope you got the question. Now comes the part that how we are required to do. Either we can do BFS or we can do DFS. We have two options, right? In BFS, DFS also how we will be doing this. So now if we want to choose BFS, in that at a particular level, whatever nodes are there, we need to swap them. But what I feel is that will become somehow complex. So I will be preferring here DFS. And why DFS? So at a particular at a particular point, whatever would be there, means whatever nodes which are there, so that I will be choosing, and that I will be swapping with just whatever is there mentioned towards its right. So in that context I will be swapping both of them because at any particular time we will be having hold of that left and right of a particular root node. That is what we will be going and just swapping them. So like that only we will be coding, and in that context the time complexity and space complexity, both of them would be order of n only. So now as we are going to do the DFS part, so now for the DFS part, first anyhow we need to check for the base case, that whatever would be the base case. If the root is not there, then anyhow in that context we will be returning null. So that's why I'm just returning null, that is all. Then we need to have whatever node which would be there at that point of time towards the left side, that we will be storing here. And how we will be getting that, we will be just calling the function itself, means the function which is here, because here I am trying to do the recursive DFS. So whatever the left subtree which is there, that will be giving us the left node, right? So for that we will be calling that left side so that we can get the left node of the same. Then for the part of the right node, we will be writing the same code, just we need to get the right side. So accordingly we'll just change it to the right and get it from the right subtree. Now after this, because anyhow it will be going to the depth and depth and depth, like that it will be going ahead. But if it encountered null at that particular, means root is not there, means if it is a leaf node, and then next whatever is there, if we encounter that, if there is null, so at that point it will return null at that point of time. Now As a toy here, what we are required to do is whatever is at the left, that should be at the right in the new tree which we are required to turn. So for that purpose we would be required to do swapping. So now when all these functions calls would be done, so it would be basically now it will start backtracking, means it will be start returning to its parent node, whatever would be there. So at that point we are required to do swapping. So now here the root left which would be there, here we are swapping. So whatever at that point of time root would be there, so whatever is there towards its left we will be assigning right, and whatever is there towards its right we will be assigning it with left. That is what we will be doing, and at the end we'll just return the root. And this all things would be performed when it will be backtracking. That's why we have chosen roots left and roots right. Whatever roots left would be there, we need to swap it with roots right, and means basically whatever right value is there at that point of time, and whatever is roots right we need to assign left value to that roots right, so that both of the values can get swapped. Even if either of value is null, anyhow that will become null, and because of that thing only will be passed to its parent node, and that is how it will go ahead. So now here we can clearly see that it is order of n solution, and even the space complexity we are not using an extra space, but it is a recursive DFS. That means it is using the stack space, so at max it can store n nodes if it is the case of that skewed tree. So that's why the space complexity, if we consider the internal stack which is there, then it is order of n, else it is order of 1. So this was all for this particular question. If you have any doubt, or if you have doubt like how all this works and so on, then you can comment that down. Although I have created videos where I have explained that how DFS is working and how all these get returned, where backtracking is being there and so on. All those videos are also there in the trees playlist. You can check out those also if you have issue with that how it is returning to parent and so on. Else it's all fine. You can just do like put those cout statements, and because of putting those cout statements as well, you will be able to get to know that how these swapping is working at what time and how backtracking is there, and that will help you to understand it more. So this was all for this particular. If you have any doubt, you could comment that down. So this was all. Thank you.